So I'm Mike Fowler. We're going to go through kind of getting started with machine learning, talk about sort of what machine learning is, the AWS stack, use some use cases, talk about what I call the forgotten service, actually called machine learning, and then a very brief overview of SageMaker. So I have to find the sweet spot to use this, I guess. There we go. A little bit about me. I've got quite a background in software engineering and data engineering. I've contributed to projects like Postgres, YAML, and Terraform. I've done quite a lot of work with Kafka, event streaming, integrating sort of machine learning as part of predictive analytics during streaming analytics. And I've collected a few certifications over the last couple of years. So one thing about me is that I like to think that I know data. Now, with any machine learning project, one thing that you do need to be mindful of is ethics. There's actually lots of ways of getting yourself in trouble when you apply an automated process, including biases in your data and so on. I'm not going to cover any of that today, but just, do think about it. So what is machine learning? It is the process of taking data, extrapolating usually something like a model or a pattern so that you can continue to make predictions or just recognize things like speech or images or text. And actually it kind of divides into lots and lots of lovely different things. The two sort of main ones are what they call supervised learning and unsupervised learning. In the case of supervised learning, you have a set of data that you know. It's typically called a labeled data set, so you know what the attribute that you want to predict, perhaps. You hand this over to various algorithms, which then try and work out a mathematical model to predict that value. And then going forward, you give it new data, and the model tells you what that value is. Now, the supervised learning is divided into a bunch of different sort of sub-things. I'm not going to kind of explore those now, but on the unsupervised learning, which is often sort of the deep learning type things, this is where you have a big chunk of data, you hand it over to an algorithm, and the algorithm tries to work out the pattern in your data. So this might be clustering the data to work out, maybe there's 4 unique things about your data. Typically image and speech and text recognition is done through this type of learning, and that's where a lot of the sort of current work is being done. So touched on a few sort of concepts. We've got these models, which are mathematical equations with the solution space approximating the outputs for the given inputs. Feature engineering, picking individual features and making new features in order to make a model. We have to train our model, but I'm not a mathematician, I'm an engineer. And that's actually the beauty of a lot of the AWS services. You don't need to understand necessarily the deep statistical modeling that goes on underneath the covers. You don't need to understand how, say, a tensor network works with all its sort of hidden layers and so on. You can actually just take advantage of a number of services. And they sort of divide into sort of 3 layers. Now don't worry that you can't see the individual pieces, but hopefully you can see that there are sort of 3 divisions. Now at the top we've got a bunch of AI services. These are models that Amazon have built with their own data, and you can just use them as an API. So you've got an image, you can send it to recognition, and it will tell you what it can see in the image. Like perhaps there's a person, there's a lamppost, there's a car. You've got services around speech, so you can have it say something, and you can also have it tell you the sort of transcription of an audio file. So these are all things where you can just start using them right away. All the hard work has been done. Now with the ML services, which is mostly SageMaker these days, plus the forgotten service, these require a little bit more work on your part, and you can kind of go to town with it if you want to, or you can just do kind of a small bits and pieces, but we'll go into a bit more detail in a moment. And at the very bottom is it's kind of the hardcore machine learning, where you've got the data scientists who know how all these things work. They're going to work with frameworks such as TensorFlow and MXNet and Gluon and Keras and these sorts of things. And so there are services for those sorts of people, but we're not going to explore that today. So, anybody ever done much with UML? That's a precision stick man there from UML. I'm very proud of it. Anyway, we're going to look at some use cases just to kind of give you an idea of the art of the possible for these API services. So let's say you have a user who uploads an image, or perhaps they're interacting with your website, you've got a product catalog, but perhaps they're visually impaired. So you take the image and you give it to recognition. There's two types of recognition. There's recognition image and recognition video. So you can do this with video. Essentially, it's a series of images. And ultimately, through Poly, you can have what has been identified in the image described. So you can actually take a service like this and just instantly add a kind of layer of accessibility on top of whatever you've got on your website, just by sending image by image to the API. Now you can do all kinds of stuff in the background, like cache the results. You can sort of tweak, it'll give you a confidence value. So it might say, that looks like a sign, like a road sign, but I'm only 60% confident in that. And so maybe you only have stuff that it's 80% confident in described through Poly. And you can, of course, script all that up to have a nice kind of branded message around, in this image you can see blah, blah, blah. So some of the companies I worked with over the years, they have like a quarterly sort of meeting, and because we've got a disparate workforce, the way they do it before things like Google Meet and the like was that they would actually record something and then phone you, and you would listen to the recording. If you missed the recording, tough. And well, actually, what if you don't, if you've got an international workforce, what if you don't speak the language of your CEO? So you can take an audio file, put it through to transcribe, and this will give you the text version of what was said. You can put it into translate and play it back through Poly. So my CEO is German, let's say. She delivers something in Germanic that gets transcribed, translated into English for me. In fact, there's several languages I could choose from if I wanted to be awkward, and play that back through Poly. Now you can see that actually with even without even a transcription, again, if you go back to kind of adding accessibility to your website, you could have a product description and add a simple little sort of pull down to say, well, here's the languages that AWS Translate supports. So select your language, boom, here you go. You haven't got to pay an expensive translator. Now, of course, it's a machine thing. The accuracy is pretty good, even on Chinese. I know somebody who speaks Chinese, and she assures me that it is fairly good. But one thing to be wary of is going from, say, English to Chinese and Chinese to English, and you sort of, that kind of loop, it starts to get a little bit funky. Now, all of these things typically use S3 in the background. Most of the APIs you can pass the data that you want to translate or transcribe as part of the API call. And more often than not, the results are put back into S3. And so actually, that's quite useful because you could just then put that behind CloudFront and start serving that up, cache your results so you don't have to pay to translate a particular product page over and over and over again. So the forgotten service, there's actually a service called machine learning, and this is one of the first ones that they put up. It's fairly rudimentary, but you can get started really, really quickly. Now, you'll notice it's got one of the old icons. Amazon seem to be changing their icon set every year now. There isn't even an icon for this one in their new icon set, so I do kind of worry that maybe they're going to drop this altogether, but hopefully it's still useful. So you need to identify a problem that you're going to solve, some particular business issue that you're suffering, and this is one that I've encountered. PagerDuty incidents coming through, wakes you up 3 in the morning, you swing your legs out of bed, and PagerDuty goes off and says, hey, it's resolved. Great, thanks very much. It's going to take me 20 minutes to go back to sleep. So obviously, you can go through and you can tune the alerting, but what happens when the next customer goes live and you got to go through that whole kind of process of tweaking and tuning? And this is the sort of thing that you might see if you've got PagerDuty integrated into Slack. 12:12 a.m., incident occurred, 12:13 it was resolved. Poor Steve Stonehouse was woken up and actually acknowledged the incident. Not particularly great. So obviously, we've got data. I don't know how many of you might use PagerDuty. There's a whole analytics section, and you can actually download CSVs of all of your historic incidents and notifications. Apologies that there is some redaction in there, but you can see that you get a fairly basic spreadsheet, nothing particularly exciting in there, but nonetheless, we've got some data that we can look and see if we can learn a pattern. So with the machine learning service, we tell it where the data is. We can be S3 or Redshift, so there isn't a huge selection here, but so we can take those CSVs from PagerDuty, throw them into an S3 bucket, and tell machine learning where that is. You will need to aggregate your CSVs, so I think it's 3 months is the widest selection period you can do from PagerDuty, but if you pull all those down, aggregate them into one giant spreadsheet, put that into S3, and here we go. So once you've done that, it will look at and try and guess the schema. Now, it's not a particularly precise schema. All it's interested in is this a numeric field? Is this a categorical field? Or is this I can't remember if it's labeled as binary or Boolean now, but that's all it cares about, because that influences the type of algorithm that it will use when you select which field you want to predict. So you can just quickly go through each, make sure that it's appropriate type. You might exclude some things. So I used a different CSV to generate this image, but in the PagerDuty example, the ID, which is a incrementing number, is not something useful for doing any sort of predicting on, because it's not actually really part of the data. It's really more metadata. Eventually, you pick an attribute to say, this is what I want to predict. So in my data set, I already know this value, and in the future, I want to try and predict this value. So if you pick a binary one, it will say, take a logistic regression. If you go for a numeric one, it will do a linear regression. And if you go for a categorical one, which is actually just much the same as a binary logistic regression, binary is just 2 possible values, and a categorical one is n number of values. Once you've done this, off it goes. It trains the model, and if it can do something, predict something, it will come back and say, here we go, we've got a model. Now, the data set you give it, it will chunk into 3 different groups. About 70% of the data it will actually use to train the model, 20% it will use to validate the model, and then 10% it will use to help tune the model. And that's because there are 3 sort of buckets that you can end up in. On the far right, my right, your left, you get an underfitted one where the data looks like that kind of waveform there, but you've predicted this kind of perfect linear line. So you give a new values in, and it will predict a value somewhere on that line. And as you can see, that's not particularly precise. On the other extreme, you can end up with an overfitted model where it matches the data set that you gave it to train with perfectly, but when you go and give it new data, it doesn't work at all. So ideally, you want the kind of Goldilocks piece in the middle there, where it's not exactly perfect to the data that you've given it, but it follows the data very well, and you'll get reasonable estimations. So once you've got a model, how might you fit this in? Now, a lot of the sort of big data architectures that I've been working with either fall into sort of 2 categories. One's called the Lambda architecture. That's probably the more familiar one, and one is the Kappa architecture. Now, for those not familiar with the Lambda architecture, essentially you have 2 sets of data. One is your historic set, and one is everything since the historic set was last updated. So with your historic set, you process that perhaps nightly in a batch type process. EMR perhaps is what you're using. Stick that into Redshift and repeat process every night. In the meantime, you have all your new data coming through, something like Kinesis streams. Perhaps that goes to DynamoDB, and then for your analytics dashboard, you combine those 2 data sets to give the mixture of all historic data and data that's occurred since you last updated your historic data set. So fitting something like machine learning into here, where you want to add some predictive analytics into your existing analytics, is just a case of sort of knitting that into something like Kinesis streams. So as the data comes in, a Lambda off to call the ML model to make a prediction, and you can then knit that in and react to it in some way. For example, you might have a sort of like an e-shopping website. customers add stuff to baskets, and maybe you've learned that the amount of time that something in the basket is correlated to the likelihood of somebody purchasing. And one customer that I've worked with discovered that there is a sort of, if something's been in the basket for about 5 to 10 minutes, there's a high likelihood that they'll purchase, and then it just tapers right off. Their thinking is that the people have kind of looked at stuff, impulse added into their shopping basket, and then sense kicks in at the sort of 5-10 minute mark. So using the ML model, they're feeding this information in. If they think that the likelihood of a sale is about to drop off, they splash up a kind of encouragement. If you purchase within the next 20 minutes, we'll give you 10% off. So SageMaker is the one that you kind of hear about, moving on from our kind of forgotten service. Now this is actually a suite of things. There's 5 separate pieces now that make up SageMaker. The first piece is actually building a model. Now I should note you don't have to use all of them to make use of SageMaker. You could build your model completely externally to SageMaker and then just take advantage of the training service, for example. But the building is a Jupyter notebook. So it's a hosted Jupyter notebook where you can go on and, particularly if you've got a lot of data scientists, they live in Jupyter notebooks. And so this is a home away from home for them. Once you've kind of built your model, you can hand it over to SageMaker to do the training. Now the beauty of this is, particularly if you have very, very large data sets, Amazon have built out a way of distributing the data set and doing the training in a distributed fashion. Because typically with a lot of ML models, they have to be trained on a single machine. It needs to know the whole data set in order to train the data. And so you need ever increasing bigger boxes. There's obviously then bottlenecks on how much data you can put through it. But the beauty of SageMaker training is that they've parallelized that for you. So why would you need to build a model when you can use something like a service, like the machine learning service? Well, what I found with the PagerDuty data is that there isn't actually enough data in there to get a sort of workable model. It's not particularly accurate. So what you need to do is break down things like, say, text values and turn them into Boolean attributes. So we have a number of different pager teams named after various characters: Mario, Luigi, Bowser. Mario and Luigi are Linux. Bowser is Windows. So you're just simply saying, well, if this data here, this is just Python Pandas here, if this data has the escalation policy named Mario, then I'm going to set the Mario attribute as a 1, otherwise I'm going to set it to 0, and so on. Some algorithms are very sensitive to the number range of your data, so there are things where you can, say, scale down your numbers to just between 0 and 1. You might kind of make your values into a logarithmic, so you might apply sort of a formula to it. And actually, some values can't be used. Now, you can remove values in the machine learning service. Here, you can just drop them all together, or you might sort of tear them apart and then remove them from the data set once you've kind of made them into numbers. Now, there are a couple of other services that are quite useful. If you've got a big, huge data set, maybe a bunch of images, and you haven't gone through the effort of labeling them all, you can use a labeling service that Amazon announced at the last reInvent. The really funky thing about this is it's actually kind of a hybrid learning. So they try and apply their models to your data, but if they can't label your data for whatever reason, it's actually backed off by Mechanical Turk, and humans will go and annotate this for you. So you can go and get a workforce effectively just by using this service. I've worked in businesses where we've had to label data sets, and you go a little bit stir crazy after a few days of kind of going through and saying, that's positive sentiment, that's negative